During this segment, we'll review what we mean by a rational function. We will also simplify and then multiply and divide rational expressions. First, let's recall what we mean by a rational expression, and you may be helped if we start with what we mean by a fraction or a rational number. Remember, a fraction or a rational number is one that can be written as the quotient of two integers as long as the denominator is not 0. Well, if you just extend that definition, you have a definition of a rational expression. A rational expression is one that can be written as the quotient, say p over q, of two polynomials as long as the denominator polynomial is not 0. Here we have an example of a rational expression. It's written of the form p over q. Notice the numerator is a polynomial, the denominator is a polynomial, and we just want to make sure the denominator is not 0, but we'll talk about that in a moment. This is then a rational expression. By the way, if I write f of x equals this rational expression, we now call this a rational function. It's a rational function because this is a rational expression. Once again, for fractions or for rational expressions, we do not want the denominator to be 0 because when the denominator is 0, then the expression is undefined. Same thing with a function. And here then we get into the domain of a function. What would be the domain of this function? Well, the domain of this function will consist of all real numbers except those that make the denominator 0, because when the denominator is 0, this expression is undefined. So what is the domain of this rational function? Well, it's the set of all numbers x such that x is a real number, but x cannot be, now what number, let's do this by inspection, what number would make the denominator 0? We do not care if the numerator is 0 because 0 over a non-zero number is just 0, but we do care if the denominator is 0. Notice if x is 7, we have 7 minus 7, 0 in the denominator. So x can be any real number, but x cannot be 7. So here is the domain of this rational function. Let's try that again. Let's look at another rational function. Let's suppose this time we're going to call our rational function c of x. Let's suppose we have a rational function c of x, and this function equals x plus 3 over x squared minus 4. Why is this a rational function? It's because this is a rational expression. Now, I'd like to find the domain of this rational function. So, the domain consists of all real numbers except those that make the denominator 0. Now, by the way, what numbers make the denominator 0? Sometimes you can do it by inspection. If you need to, let's just take a moment and let's set that denominator equal to 0. Forget everything else and concentrate on this equation. How do you solve this equation? It is a quadratic equation, so remember you'd use the zero factor property. You want 0 on one side and a factored polynomial on the other side. This is the difference of two squares, so it factors as x plus 2 times x minus 2, and then if you set each factor equal to 0, setting this factor equal to 0, x is negative 2. If you set this factor equal to 0 and solve, x is 2. So these two numbers make the denominator 0, and you can certainly check. Negative 2 quantity squared is 4, minus 4 is 0, and 2 squared, that's 4, minus 4 is 0. So, again, now let's get back to our domain question. The domain of this rational function is a set of all numbers x such that, we read that as such that, x is a real number, but x cannot be 2 and x cannot be -2. There we have the domain of this rational function. So here's how we simplify a rational expression. Step 1, completely factor the numerator and denominator. Step 2, divide out factors common to the numerator and denominator. This is the same as removing a factor of 1, and I'll show that in just a moment. All right, so let's simplify this rational expression if possible. We want to begin by completely factoring the numerator and denominator. Look at the numerator alone. What is the first step in factoring any polynomial? It is to look for a greatest common factor if there is one other than 1 or -1. Notice there's a common factor of 5, and in fact, I'm going to factor out a -5 because if I do so, I know I'll have an a plus b left, which will be the same as the factor in the denominator. So I will begin by factoring the numerator, and I will factor out a common factor of -5. Now be careful with signs. This divided by -5, or as we factor it out, we have left a, and then here is a very important part. What is the sign as we factor out -5? The sign is plus, and then factoring out the -5 plus b. And you can always check, if unsure, check by multiplying. This times this is that, and then see -5 times a positive b is -5b, and we write it as -5b. And then, of course, in the denominator, I have a plus b. So we have completely factored the numerator. The denominator is factored as far as we can factor it. We have a plus b. Then remember, step 2 is to divide out common factors, which is the same as removing a factor of 1. Now let's talk about what we mean by removing a factor of 1. What it means is this. Okay, can you agree that I can write this as, say, -5 over 1 if you want, times a plus b over a plus b. Parentheses if you want, but since I've separated it, I don't need the parentheses around the a plus b any longer. In other words, this times that numerator is that, and that times that denominator is that. But what do we know is anything over itself? What is a plus b over a plus b as long as the denominator is not 0? This simplifies to 1. So in essence, I have -5 over 1 times 1, and -5 over 1 times 1 is just -5 over 1, which is just -5. So what is essentially happening is that we are removing factors of 1. You don't need to go through this step every time. You can just divide out once you see a common factor in the numerator and denominator. But I have simplified this rational expression, and it simplifies to -5. Let's go over a few other examples just to make sure we're aware of a couple of instances. Let's suppose I have x plus 7 over 7 plus x. This is a rational expression. I want to simplify this rational expression. Are these factors the same in the numerator and denominator? In other words, is x plus 7 the same as 7 plus x? The answer is yes, because remember, addition is commutative, so I can take one of these. It doesn't matter which one. Maybe I'll take the factor in the denominator, and I can write it as x plus 7. In other words, 7 plus x is the same as x plus 7. we do have common factors here in the numerator and denominator of x plus 7. Make sure you know that this is a common factor with this. And don't forget, although I won't write it down every time, you're dividing out common factors. So x plus 7 divided by x plus 7 is 1. And the same thing here, it's 1. So you end up with 1 over 1, which is simply 1. Now you may need to take a moment and study this example. Let's compare this example, though, with a similar example, but this time subtraction. Let's suppose I have this rational expression. All right, I have x minus 7 over 7 minus x. I'd like to simplify this rational expression. Is subtraction commutative? Does order matter when subtracting? The answer is yes, so this does not simplify to 1. Can we simplify at all here? The answer is yes. We can do the following. Pick either the factor in the numerator or the factor in the denominator. It makes no difference. I'll pick on the factor in the denominator, and I will factor out a negative 1. Watch what happens when I factor out a negative 1. What is 7 divided by negative 1? Well, that's negative 7. And I can think of this as negative x divided by negative 1, which is a positive x. So I can write plus x. Now double check. Negative 1 times negative 7 is positive 7. Negative 1 times a positive x is negative x, so that is minus x. I have not changed anything. I've just written an equivalent form. But I'm leaving the numerator alone. In the denominator, I'm just going to rearrange the order here. Since this is a plus sign, I can put the x first and the negative 7 second, so I can make it x plus negative 7, or equivalently x minus 7. Now these factors are exactly the same. This does simplify, but it doesn't simplify to 1. What does it simplify to? It simplifies to negative 1. So be careful with this. Make sure you are aware of this and study it, and we will continue to simplify rational expressions. Study this a moment. This is a rational expression. I want to simplify it. So we'll go through those two steps. Let's completely factor numerator and denominator. Let's look in the numerator. What's the first step to factoring? It is to factor out a greatest common factor. If there is one, and it is x squared. So factor out x squared. When you do so, you have left x plus 7. And the numerator cannot be factored further. Now let's factor the denominator. No greatest common factor. If this does factor, I'm looking for two numbers whose product is negative 14 and whose sum is positive 5. So that's x plus 7 and x minus 2. We have completely factored numerator, completely factored denominator. And now we look for any common factors in the numerator and denominator. Notice we have a common factor of x plus 7 with a common factor of x plus 7. So we have left x squared times 1, if you'll have it, which is x squared, over 1 times x minus 2, which is just x minus 2. You can place it in parentheses or not in parentheses in the denominator. It's up to you. Now my question to you is it fully simplified? Can I, for example, divide out an x here and an x here? The answer is no, because although x is a factor in the numerator, because that's x times x, x is not a factor. Factor means written as a product. This is x minus 2, so we may not divide out this x. This is simplified, and there I have it in simplest form. I want to simplify this rational expression. Let's completely factor numerator and denominator. This is the difference of squares, so it's 2 plus x times 2 minus x. I'll let you check that by multiplying. And in the denominator, I have simply x minus 2. So I've completely factored everything. Do we have any common factors? Not exactly, but notice we have 2 plus x and x minus 2. Remember, those are what we call opposites of each other. So let's see what we can do. I'll rewrite my numerator, and it doesn't matter if you pick on this factor or this factor, but I'm going to rewrite one of them. I'm going to factor out a -1, and remember from our previous work, if I do, I then do have 2 minus x. Now double check, -1 times 2, that's -2, -1 times -x, that's positive x. So I haven't changed anything, but now these factors are exactly the same, and this is 2 plus x over -1. I can write that as negative parentheses 2 plus x, or I can go ahead and distribute it and write it as -2 minus x. Both of these are okay, and I have simplified. Let's talk a little bit more about equivalent forms of rational expressions. Often, it will be advantageous for us to know what we can do with this negative in front of this rational expression. To help you remember, let's recall something like just a regular fraction, -2/3. Recall that -2/3 is equal to -2/3, and that's equal to 2 over -3. In other words, I can write this negative sign in front of a fraction in the numerator or in the denominator. These are all equivalent. Just as we can do for fractions, we can do with rational expressions. We just have to be careful because a lot of times, for example, in this example, the numerator contains more than one term and the denominator contains more than one term. We're just going to start writing equivalent rational expressions. In other words, I can take this negative out in front. I can move it to the numerator. Let's go ahead and write it down here. If I move it to the numerator, I need to write parentheses around that numerator because this negative sign does apply to the entire numerator. So this is equivalent to this, and since it is equivalent to this, I can also go ahead and distribute the negative in the numerator. That would be -x minus 11 over x minus 4. This is equivalent to this, which is also equivalent to this. Now, what else is it equivalent to? You can look back here to begin with again, but I can also move the negative in the denominator. So it becomes x plus 11 over negative parentheses x minus 4. Just using those same rules that we have used with fractions. And so this is equivalent to this and every other rational expression right now on the board. Because of that, do you see I can do the same thing? I can distribute the negative in the denominator and make it -x plus 4. All of these rational expressions are equivalent, and during different times you might see any one of these forms. So make sure you study this and know that these are all equivalent rational expressions. The total revenue from the sale of a popular book is approximated by the rational function r of x equals 1000x squared over x squared plus 4, where x is the number of years since publication and r of x is the total revenue in millions of dollars. So let's see if we can answer some questions about this rational function and how it pertains to the application. How do we find the total revenue then at the end of the first year? To find the total revenue at the end of the first year, we find R of 1. So what is R of 1? Everywhere there's an X, we put 1. So this is 1,000 times 1 squared over 1 squared plus 4. And what is that? 1,000 times 1 squared, that is 1,000. Over 1 squared is 1, plus 4 is 5. What is 1,000 divided by 5? That's 200. So R of 1 is 200. How does that apply then to this question? What is the total revenue at the end of the first year? It is, remember, R of X is in millions of dollars. So the answer is $200 million. $200 million. Now that's A. Notice B, we're asked the following question. Find the total revenue at the end of the second year. So let's see what the total revenue is at the end of the second year. And you tell me or be thinking about how we do this. All right, so the end of the second year. The total revenue by the end of the second year, that's R of 2. Let's find R of 2. That's 1,000 times 2 squared. You can put it in parentheses or not. It's up to you. Over 2 squared plus 4. So let's see what that is. 2 squared is 4. 4 times 1,000 is 4,000 in the numerator. What do we have in the denominator? 2 squared is 4. 4 plus 4 is 8. And then what is 4,000 divided by 8? Well, that's 500. So in the context of this problem, at the end of the second year, the total revenue is 500 million. And you can continue doing that. But let's answer, now that we've answered part B, let's now answer part C. And what does part C say? We want to find now the revenue during the second year only. So this is a total revenue. Total revenue from the first year and second year is 500 million. Total revenue into the first year is 200 million. So now we want to find the revenue. Let's write this down so you can see it. Find the revenue during the second year only. Now, if you're wondering, well, what did we just do? We found the total revenue. R of 2 is the revenue for the first year and second year. It's the total revenue. Now, during the second year only, how do we do that? Well, we take the revenue from the first year and we subtract it from R sub 2, the total revenue by the end of the second year. Now, if you remember, the total revenue all the way through to the end of the second year is 500 million. The revenue for the first year is 200 million. So it's 500 million minus 200 million, which is 300. And in the context of this problem, then during the second year only, sales generated $300 million. Now, what about part D? Part D, we just want to find the domain of the rational function. All right, so part D, let's find the domain. Look at the denominator. We want to make sure the denominator is not 0. So the domain is a set of all x such that x is a real number. Now, are there any real numbers that will make this denominator 0? The answer is no. If you set this equal to 0, you'll end up with something that doesn't factor or we haven't talked about complex numbers, but you would actually end up with complex number solutions. And right now we're just in real numbers. There's no real number that makes the denominator 0, so the domain is the set of all x such that x is a real number. Let's now check our understanding of simplifying rational expressions by answering the following question. The question is, the expression 7x minus 35 all over 7 simplifies to choice A, x minus 5, choice B, x minus 35, or choice C, 7x minus 5. If you need to, pause, work it out, take a moment, and then make your selection. Choice A is the correct choice. Let's see why. Remember how you simplify an expression? If we factor the numerator, we can factor out a common factor of 7, and we have left x minus 5. And then there is that 7 in the denominator. So what are common factors, or what is the common factor here? There is a common factor of 7, and you have 1 times x minus 5 all over 1, which is the same as x minus 5. This is the correct choice. Choice B is not the correct choice. Let's discuss why. Recall that you cannot divide this 7 with this 7. Although this is 7 times x, it is the expression 7x minus 35. So because of that subtraction, you cannot just divide out this 7 with this 7. What is the appropriate way? Just remember those steps. Completely factor the numerator, and if you do so, you'll factor out a common factor of 7, have left x minus 5 over 7. Then the 7s can divide out because this is 7 times an entire expression. So the 7s do divide out, and we have left x minus 5. The correct choice is choice A, and that is x minus 5. Choice C is not the correct choice. Let's discuss why. I'm guessing that possibly you arrived at choice C by dividing 7 into 35. Now, it is true that if you just had 35 over 7, that does simplify to 5, but this is an entire expression in the numerator. So you cannot just choose a term of an expression and simply divide out with that term. We need to go through our steps. Remember to first factor. So in the numerator, notice there's a common factor of 7. And in the denominator, I do have a 7. Then the 7s do divide out because this is now 7 times an entire expression. So the 7s do divide out, and we have left x minus 5. This simplifies to x minus 5, which is choice A. A is the correct choice.